Hello friends, this video is created by Siddharth Upadhyay, founder and creator of PrepWings. Log on to www.prepwings.com for complete free course videos. Okay, in this video we'll talk about inequalities. Inequalities can be of the following types: greater than, less than, greater than equal to, and less than equal to. Okay. Now, first we'll look at what happens if we add a number in an inequality. So for example, if A is greater than B, then if we add C on both the sides, the inequality becomes A plus C is greater than B plus C. As an example, we can see 5 is greater than 3. Now if we add 2 on both the sides of the inequality, we'll get 5 plus 2 is greater than 3 plus 2. Okay, 5 plus 2 is 7 and 3 plus 2 is 5, which is true. Okay, so if we add a number in an inequality, the inequality remains the same. Okay, it means if it is greater than, it will remain as greater than. If it is less than, it will remain as less than. Okay, the same thing goes when we do subtraction in inequalities. Okay, if A is greater than B, then if I subtract C on both the sides, it will become A minus C is greater than B minus C. Again, we look at an example. 5 is greater than 3. Now if we subtract 2 on both the sides of the inequality, we'll get 5 minus 2 3 and 3 minus 2 1, and we know 3 is greater than 1. Okay, so the inequality sign has remained the same. Okay, now when we do multiplication, we have to be careful of the number that we are multiplying the inequality with. Okay, so if A is greater than B and if C is greater than 0, means when C is positive, only then we can conclude that A into C is greater than B into C. Okay, we look at an example. 5 is greater than 3. Now 2 is a positive number which is greater than 0. Thus if I multiply the inequality by 2, my inequality sign, which is greater than here, doesn't change. So 5 into 2, which is 10, and 3 into 2 is 6, and 10 is greater than 6. So as you see, the inequality sign doesn't change. But if we multiply an inequality by a number less than 0, which means a negative number, then the inequality sign reverses. Okay, so if it is greater than, it will become less than. If the inequality sign is less than, it will become greater than in that case. Okay, so A into C will be less than C when C is less than 0. Again, we look at the example. 5 is greater than 3. Now if we multiply this inequality by minus 2, okay, 5 into minus 2 will be minus 10, and 3 into minus 2 will be minus 6, and now minus 6 is greater than minus 10. So if you look at it, the inequality sign was greater than because 5 was greater than 3. Now it has reversed to less than because minus 10 is less than minus 6. Okay, so always be careful when multiplication is happening in an inequality. If I multiply with a positive number, then the inequality sign remains the same. If I multiply the inequality by a negative number, the inequality sign reverses. Okay, now we look at division in inequalities. Division follow the same rule as multiplication. So if we divide an inequality by a positive number, then the inequality sign remains the same. So again, we see the example here. 6 is greater than 3. Now we divide this inequality by 3, which is a positive number. So 6 by 3 is 2 and 3 by 3 is 1. Okay, so 2 is greater than 1. And if you look at it, the inequality sign remained the same because 6 is greater than 3 and 2 is greater than 1. Okay, the sign didn't change. But if we divide an inequality by a negative number or a number less than 0, then the inequality sign will reverse. Okay, so 6 is greater than 3. Now if we divide this inequality by minus 3, okay, which is negative, then it will become 6 upon minus 3, which is minus 2, and 3 upon minus 3, which is minus 1, and minus 2 is less than minus 1. Okay, so 6 was greater than 3, but if I divide this inequality by a negative number, I will get minus 2 less than minus 1. Okay, so the inequality sign has reversed. So as in the multiplication, in division also the inequality sign reverses when we divide an inequality by a negative number. Okay, we'll do a question here. We have been given 3x minus 5 is greater than 7. Okay, So now if we add 5 on both the sides, 3x minus 5 plus 5. So minus 5 and plus 5 will cancel out each other, and on the right hand side of the inequality it will be 7 plus 5, which is 12. So what we will get is 3x is greater than 12. Now we will divide this inequality by 3 on both the sides. So on the right hand side of the inequality, it will be 12 by 3, which is 4, and on the left hand side it will be 3x by 3, which is x. And I am dividing by a positive number, so the inequality remains the same. It will still be greater than. So we get x greater than 4 as the solution here. Okay. Now we look at another question. We have to solve minus 3x minus 5 is greater than 7. Okay. Again we'll add 5 to the inequality on both the sides. So we get minus 3x is greater than 12. Okay. Now we will divide this inequality by minus 3 because we need x on the left hand side, right? So when we divide by minus 3, the inequality sign should change. So when we divide this by minus 3, we get x on the left hand side, and 12 divided by minus 3 is minus 4. And the inequality sign reverses. Instead of greater than, it becomes less than. Okay. So it has reversed from greater than to less than. Okay. So our final answer will be x is less than minus 4. Now we will look at inequalities in case of polynomials with power more than 1. Okay. So basically we will be looking at how to solve inequalities of quadratic expressions and expressions of higher powers. So we'll follow the steps given here. First of all, we'll arrange the expression such that one side of the inequality is equal to 0. Okay, so whatever number is there on that inequality, we will basically take it on the other side of the inequality, okay, to make it 0, that side. Then we'll factorize the expression in x. The third step is we'll find the values of x for which the expression is 0 and plot them on a number line. Okay. The fourth point is the number line will be divided in different regions after plotting the values, and then we'll have to pick any value in a region and to check whether it satisfies the inequality or not. If the value satisfies, then any value in that region will satisfy. We'll look at a few examples now. Okay, we'll look at an example now. The question says x square plus 5x plus 6 is less than 0. Now here we'll factorize the left hand side first, which will give us x plus 3 into x plus 2 is less than 0. Okay. Now we'll plot minus 3 and minus 2 on the number line, because x plus 3 into x plus 2 at values minus 3 and minus 2 is equal to 0. We'll plot the points in which this polynomial equals to 0. Okay, those are not the answer, by the way, because this is an inequality. This is not an equation. Okay, we are just plotting those points, minus 3 and minus 2. So minus 3 and minus 2, when we plot on the number line, we see three regions, R1, R2 and R3. R1 is the region on the left hand side of minus 3. R2 is the region between minus 3 and minus 2, and R3 is the region on the right hand side of minus 2. Okay. Now what we'll do is we'll pick up a value in any one of the regions. Okay. So suppose we pick a value in region R1 as x is equal to minus 4. Now if we put x equal to minus 4 in the expression x plus 3 into x plus 2, we get minus 4 plus 3 into minus 4 plus 2, which is equal to minus 1 into minus 2, which becomes minus 1 into minus 2 is equal to plus 2, positive 2. Okay, but the inequality says that the product should be less than 0 of x plus 3 into x plus 2, and 2 is greater than 0. Thus this inequality is not satisfied in this region. So region R1 is rejected. Now we put x equal to minus 2.5 from region R2. Okay, so in the expression x plus 3 into x plus 2, so we get minus 2.5 plus 3 and minus 2.5 plus 2. Minus 2.5 plus 3 is 0.5, and minus 2.5 plus 2 is minus 0.5. So this will become 0.5 into minus 0.5, that is minus 0.25. Okay, now if you look at the inequality, x plus 3 into x plus 2 should be less than 0. That means it should be negative. And our answer over here is coming out to be negative. Thus this inequality is satisfied in this region. Thus region R2 is selected. Similarly, we'll take a value in region R3. So we take x is equal to 0 over here in region R3. And we put it in the expression x plus 3 into x plus 2. What we get is 3 into 2 then, which is 6. Again, 6 is greater than 0. Thus it doesn't satisfy the inequality. So region R3 is rejected. So now what we have is, we have rejected region R1, we have selected region R2, and we have rejected region R3. Okay, so any value of x in region R2 will satisfy the inequality. Okay, thus x has to lie between -3 and -2 for this inequality to be true. Okay, thus our answer is x lies between -3 and -2. Okay, now we look at another example. It says solve x minus 2 into x plus 1 into x plus 3 is greater than 0. Okay, over here if you see, we already have the left hand side factorized. Okay, so it has already been factorized. We'll plot x equal to 2, x equal to -1 and x equal to -3 on the number line, because at those values this expression is equal to 0, the polynomial expression on the left hand side. So when we plot these points, we divide the number line into 4 regions. Okay, region R1 is on the left hand side of -3, R2 is region between -3 and -1, R3 is region between -1 and 2, and R4 is the region on the right hand side of 2. Now what we'll do is, we'll pick a value in each region and we'll check if that satisfies the inequality or not. Okay, so now picking a value in region R1, we say pick -4. Our inequality is x minus 2 into x plus 1 into x plus 3 is greater than 0. This is the inequality. So we'll put x equal to -4 over here. So in the expression x minus 2 into x plus 1 into x plus 3, what we get is -18. -18 is not greater than 0. Okay, because it is a negative number. So that means this value is not satisfying the inequality. Okay, so region R1 is rejected. Now region R2, we take x equal to -2. Again, we'll put it in the expression x minus 2 into x plus 1 into x plus 3. We get 4 as the answer, and 4 is positive, which is greater than 0. So region R2 is selected because it satisfies the inequality. Similarly, in R3, we take x is equal to 0 and put it in the expression to get the value as -6. Okay, so -6 is also not greater than 0. So this is also not satisfying the inequality. So region R3 is rejected. Same for R4. What we do is, we take x equal to 3 here, put it in the expression x minus 2 into x plus 1 into x plus 3 to get the result as 24, and 24 is greater than 0. So that means region R4 is selected. So what we have is, R1 is rejected, R2 is selected, R3 is rejected, and R4 is selected. If you look at it closely, what we have is, if we reject R1, we have to select R2. Then we have to reject R3 and we have to select R4. So all these rejection and selection of regions are alternate. So what we could have done actually is, we just would have found R1 has to be rejected. So if R1 is rejected, then R2 has to be selected, R3 has to be rejected, and R4 has to be selected, because these are alternate. Okay, so keep in mind, we don't need to check for all the 4 regions going ahead. We just check it for one region and then alternately put reject, select, reject, select. Okay, depending on what we get first. So over here, R1 is rejected, R2 is selected, R3 is rejected, and R4 is selected. Thus, the values of x satisfying this inequality will lie in region R2 and R4. So x has to lie between -3 and -1, or x has to be greater than 2. Thus our answer is x lies between -3 and -1, or x is greater than 2. Now we will be looking at inequalities for absolute value. So we know that absolute value of a number is the distance of the number from 0 on the number line. Okay. So now if we are given an inequality of absolute value of a less than 5. Absolute value of a means distance of a from 0 on the number line. Okay, so absolute value of a less than 5 means that distance of a from 0 on the number line is less than 5. Okay, So what it means is that A lies between minus 5 and 5. Okay, because if you pick any number between 0 and 5, let's say we pick 4. 4 is at distance 4 from 0 on the number line, which is less than 5. Okay, so that means 4 satisfies the inequality. Similarly, if I pick minus 4 is at 4 units from 0 on the number line. So minus 4 is also at the distance 4 from 0, which is less than 5. Okay, so minus 4 also satisfies. Okay, so what we need to know is that if absolute value of A is less than 5, it means distance of A from 0 on the number line is less than 5. The distance can be in the positive direction as well as in the negative direction. Okay, so looking at this number line, the solution set of A is that A lies between minus 5 and plus 5. Okay, this is how we deal with absolute value and inequalities. Now over here we'll do a question of inequalities and absolute value. The question says absolute value of x minus 3 is less than 7. Now what it means is the distance of x minus 3 from 0 should be less than 7, and the distance can be both on the positive and the negative side. Thus what we have is x minus 3 lies between minus 7 and 7. Okay, because for example x minus 3 can be equal to minus 6, because minus 6 as it is at a distance of 6 from 0, which is less than 7. So that will satisfy. Okay, similarly x minus 3 can be equal to 6, because again 6 is at a distance of 6 from 0 on the number line. Okay, so going by that logic, x minus 3 lies between minus 7 and plus 7. Okay, thus x minus 3 lies between minus 7 and plus 7. So in this inequality, if I add 3 across all the three terms, what we get is x lies between minus 4 and 10. Okay, so this is all about inequalities. Thanks a lot for watching this video.